All right, there we go. All right. So, all right, 11.6. Like I said, I do have exams. I'll pass those out in between problems here. So, 11.6, we're solving systems of nonlinear equations. System means more than one equation at the same time. Notice we have two equations. But we've done that before, right? I mean, we just finished sections where you have two equations at the same time. We even did three, right? You even did three. I mean, you used your calculator, right? But you did three equations at the same time. So that's not new. We've done systems, but what is different about this system from the other systems you just did in 11.4? Yeah, see it says nonlinear. What is linear? What is a linear equation? First power. Linear means first power on x and first power on y. That's what, right? Because you get a line. If you graph something where x and y are to the first power, you get y equals mx plus b, right? Right? Y first power, x first power. That's a straight line, isn't it? Some kind of a line. So anything where you have x squared or cubed, as you've seen many times now, or even y squared, you start getting bending, ellipses and parabolas. You guys know quite a bit about all that now, right? That's what brings the curvature into graphs, is when you have higher powers on x or on y. It's not linear anymore. So they say this section is non-linear. Notice this second one. The second one, x and y, are to the second power. So it's not a line. So those are not two line equations. And thus, they're not, if it was two lines, what do two lines do on a graph? Well, two lines do something like that and intersect at one point, don't they? Or they could be infinite, or, no solution or infinite. But in general, what two lines do is intersect in one point, right? That's what they most typically do. So that's not going to happen here, because these are not two lines. They're two curvy things. In fact, you know what the second one is, right? What is this one? What kind of equation is that? We just finished the section. Do you remember? What is that? So first off, could it be a parabola which only has one branch? No, because it's got both letters squared, not one. Did you learn that? I hope you learned that. And when the final exam is coming, I'll just plop them down and I'll say, graph this thing. And you got to be able to recognize, right? If you've only got one letter squared instead of both, that would make a parabola. That's why there's only one branch on a parabola. You go right, left, up, or down. Whereas the other ellipse and hyperbola, they have x and y squared. Thus, they have two branches. If you got a plus in between those two branches, get together, make an egg shape. If there's a minus, called an ellipse. If there's a minus in between the two branches, turn away. They have a negative relationship, right? They turn away from each other, either up, down, or right, left. So, what is this then? X and y squared, plus in the middle, ellipse, right? Hyperbola, they turn away. If there was a minus in the middle, they'd be turned away. They'd have a negative relationship. It's plus in the middle. They're happy. They have a happy, happy relationship. They get together, they make the egg shape, the ellipse. So anyway, that's a lot of is an ellipse. All right, so what? Now the first thing you actually haven't seen probably. It almost looks like a linear, huh? Because x and y are to the first power. It's not. It turns out, even though according to what I just said, it should be, because I didn't tell you the whole story. I'm always kind of half lying to you. Well, really, the truth is, I can't, there's just too much to tell the whole story all the time, so I kind of give it in pieces. So here's a little more of the story. X and y first power and not multiplied, really. Because if you have x times y equals 3, that's almost like x squared. It's two letters multiplied. It's really x squared. It's really curvature. So x times y equals 3 is going to actually be something that has bending in it. It's not linear, even though x and y are just first power. Really, they're multiplied, so it's like second power, really. So that's the whole story now. Now, I'm not lying to you anymore. So that's really the whole story. When x and y are first power and not multiplied, it's linear. That's true. That's completely true. I mean it this time. That's really the truth. But if x and y are multiplied, turns out that's a hyperbola. That's a fancy, I know we didn't talk about those, that's a fancy kind of hyperbola. I know it doesn't look like what you're used to. It's a bent hyperbola. Anyway, it's a branches turned away, but then they've cocked it diagonally. It's a diagonal hyperbola. Anyway, we don't need to worry about all that. But let me tell you, you tell me, if you have an egg shape, right, which is that second equation. I don't know where it goes exactly, but it's some kind of ellipse. And then you have bent hyperbola branches like that, which is what the other one is. That xy equals 3 is a diagonal hyperbola. So how many intersections, because that's what we're looking for ultimately. We're not going to graph them, but just ahead of time, how many intersections would you expect?
4.
Yeah, 1, 2, 3, 4. At most. It could do other things, right? You could have the egg shape, and it barely nicks, and just have 2. Or it could just miss. It could just be out here, and none. No solution. Huh? So we're looking for either no answers, 2 answers, or 4 answers, aren't we? Those are the possibilities when a hyperbola and an ellipse get together, which is what we have here. All right, so anyway, that's enough with the pictures. Let's get to the actual solving. So how do you do it? Well, I'm going to use substitution, meaning I'm going to plug one equation into the other, right? So solve basically here's the game plan. Number 1, start with the easier equation. Which one looks easier? It's that top one, because that's just first power. That's what I mean by easier and harder. Usually there's going to be an easier one where x and y are just first power, and then a harder one where it's second power and stuff. So when you have an easier and a hard one, start with the easier one and solve for x or y, it really doesn't matter which one, and plug into the other. So that's our first step. Let me see if I can, well, I'll just do it down here. So I'm going to take that first equation, x times y is 3, and I'm going to solve for x or y, it doesn't matter. I'll just go ahead and divide by y. So I end up solving for x, but you totally could have done y, it doesn't matter. Is that good so far? Am I making sense? Then I take the second equation and I plug that in for x, because I happen to solve for x. Is that good to there so far? Getting a little scribbly there. Everybody good to there? So then we just got to solve that equation for y. It's just kind of a big old mess. If you guys got that copied down, I'll go to a new screen. So here, maybe I could just redo it again real quick. So the top equation, x is 3 over y. And the second equation, plug in right there. Okay, so then now how do we work out? There's a lot of messy algebra. This is a pretty hard section as far as there's a lot of messy algebra. It's good practice if you're headed to calculus. So how do you square 3 over y? Well, it'll be 9 over y squared. Good so far? I just squared the 3 and squared the y to become 9 over y squared like that. Is that okay? And now, how does a whole number like 3 interact with a fraction? It's just over 1. It just goes to the top, huh? So 27 over y squared plus y squared is 12. Good so far? Now, basically, whenever you have fractions in the problem, denominators and stuff, I think it's easy. There's different things you can do, but I think it's usually easiest just to multiply through by that denominator. You know, the y squared in this case. So I'm just going to go y squared, y squared, y squared. Just going to multiply all the way through the equation, every term, by y squared. It cancels in the first spot. That's why we did it, huh? And so then we get 27 plus y to the 4th, actually, huh? Equals 12y squared. It's good so far. There's our 4th power. Remember how we're expecting 4 answers? See how it's coming about like we were expecting? You guys are getting into higher and higher math now. I think things get more interesting as you go higher up. You start to see graphs and equations agree and get more of the deeper story, and it's more interesting. Okay, so we get to here, and now, well, what should we do with this thing? This 27 plus y to the fourth is 12y squared. Basically, I bet you could guess. It's what we do whenever we have y squared. We always get a 0, and try to factor. It's that same kind of thing. So the game plan just, when you got, where should I write it? Higher, am I on the screen there? Higher powers. When you got higher powers, second, third, fourth, it is basically try to get a 0 and factor. That's usually how we want to go. So I'll just bring this over here, and I'm going to reorder it. So put the y to the fourth in the front, minus 12y squared plus 27 equals 0. Yeah. Is that good to there? And then factor that thing. So what's that? 3 and 9 to make 27. Both minus. We'll make the minus 12. And remember, they gotta add to be the middle, and they multiply to be the number on the right. Remember how that works? So the two negatives multiply to be plus 27, and they add to be the negative 12 in the middle there. And then if two things are timesing to equal 0, if I said, hey, I'm multiplying two numbers and the answer is coming out 0, you know what that would mean, huh? If I'm multiplying two numbers and the answer is coming out 0, either one could be 0, right? To make a multiply to be 0. So either one is 0. So that means either the y, kind of do a separation here. Either the y squared minus 3 is 0, or the y squared minus 9 is 0. Either one could be 0 to make a multiply to equal 0. So then you just solve each of these equations. Jump that over, jump that over. Y squared is 3, y squared is 9. And now, what do we do to finish these guys? To get regular y, I mean? Yeah, root. You got to put the root over both sides. You got to do the same thing to both sides always. What happens when you put the roof on the house? Remember my little saying? Up and down the ladder, I hope, because it's really important in this section to remember you got to do the plus or minus. When you put a roof on the house, you got to go up and down the ladder. It's a dorky little saying, but hopefully hope you remember. Same thing here. Roof on the house, up and down the ladder, plus or minus regular 3, huh? So there's our 4 answers, just like we were kind of expecting. 4 answers. Plus and minus root 3, plus and minus regular 3. 4 different answers. Now those are all y. We have to go back now and get x. These are long. So we got our y. Let's go on. If you guys have that copied down, I'm going to go on and finish this problem up, maybe with one more screen. So we have y is plus or minus root 3 here, and y is plus or minus regular 3 there. So that's all step 1. Step 2 is now plug answers. Now, the deal is what's a little different about these is we have 2 equations. Normally, when we have 2 linear equations, I'll say it doesn't matter, plug it in wherever you want. But in this case, one of those equations is a fair bit easier to deal with than the other. So plug your answers into the easier whenever you have a choice. So plug into easier. So, okay, what did we have? We had x. If you take that first equation, which is the easier one, x and y are first power. It was, 3 over y, huh? Got that upside down. It was 3 over y. So that was the first equation. So plug in the plus or minus root 3 to that. So you get x is 3 over plus or minus root 3. Can I just do them both at once? It's going to do the same thing, plus or minus. We're just going to get the 2 different answers. Now, we can't leave an answer that way. With a root on the bottom, I mean, Math Excel won't accept it. Can't leave a root on the bottom. Your calculus teacher probably won't accept it either. So what do you do with a root on the bottom?
Multiply the top and bottom by square root.
Yeah, multiply top and bottom by root 3. That's a fine way. Let me give you something. You can do that, and that's great. Let me give you something that'll save you time if you notice it. Isn't 3 on the top really root 3? Isn't that the same as 3? Right? Root 3 is root of 9, which is 3. Right? And then that's just quick. So that's just a quick way to do it. We're going to get the same answer if you want to multiply top and bottom by root 3. I'm just showing you kind of like a shortcut. When I look at that plain 3, in my mind I think root 3. I just see it that way. And then, boom, I know one cancels. So I just look at that and go, oh, it's 2 root 3s. One's going to cancel. It's just plus or minus root 3. If you want to save time. But I'll show the more formal method also. You're right. You multiply it by root 3, top and bottom, and so that's 3 root 3 over plus or minus. What's root 3 root 3? Plane 3. They cancel. Same answer, huh? So the answers for x are plus or minus root 3. So now we've got to be kind of careful on that. What does that mean, though, is our actual, like, they want ordered pairs. That means positive root 3 for x, positive root 3 for y, negative root 3 for x, negative root 3 for y. Is that okay? Right? The positive goes with the positive. And that's not always the case. Yeah, I'm probably being too casual. Let me back up, guys. I'm just trying to save time, but I'm cutting too many corners probably. I probably should have just put in the plus first. And then you would have got the plus. Because sometimes they switch. Sometimes the plus x or y or whichever will go with the negative of the other. Sometimes a positive will go with a negative and a negative with a positive. It just depends. So you really probably shouldn't do plus or minus all at once. You might lose track of which one's happening. So just do the plus first off. Just do the plus, and it comes out to be the plus. And then you could just go, oh, I know what's going to happen with minus. The minus will just go to minus. So the plus goes with the plus, and the minus goes with the minus. That's probably the best way to go. And then on the other side, same thing. Just plug into x equals 3 over y. Plug it in. I'll just do the plus. So 3 over 3. So x is plus 1. So then you go, oh, plus 3 goes with plus. So plus 1x. Careful to put x first. Goes with plus 3y. And so guess what would happen if I did negative 3y? It would lead to negative 1, right? Are we okay? If I made this instead of plus 3, if I did the minus 3, it would be negative 1, wouldn't it? So xy, xy. So there's our 4 answers. They want you to put in all 4 with a comma. It takes a long time just to type the answer in. There it is. Any order, but x always has to be first, followed by y. But any order for the 4 points. We got 4 points where those two graphs intersect. And it only took us 20 minutes. That's why there's only 6 of these, or 10. Oh, there's 10. Sorry. There's 10 of these. All right, is that good? Questions on that? So most of it you know how to do, you know, but it's teaching. Okay, so let's do that one, and then after that we'll go on to one of the like termers. So notice one of the equations is easier than the other one. Which one is easier? That second one. Yeah, so start with the second one. And what would be the easiest letter to solve for there so you don't have fractions or anything? Y. Just get that y alone, right? So step 1, get y alone in the second equation, right? 2x plus y is 7. Just jump that 2x over. Y is 7 minus 2x, like that. And then plug that in to the top equation everywhere you've got y. And work it out from there. Okay, so plug that into the second or the other equation. The other equation, which is 9x squared minus xy plus y squared. These are a mess. So plug that whole thing in there and there, so you get 9x squared minus x times y, which is 7 minus 2x plus y squared. So 7 minus 2x, 7 minus 2x. Right? The squared, you know, I hope that you got to, on that squared, you got to write the parentheses twice, right? You can't just square the 7, square the 2x, and get 49 minus 4x squared. That's wrong. Really important you know that. Deaf to the calculus student who thinks that way, right? That's just indicator that there's a lot of algebra they don't know. Everybody good with that? You got to write 2 of those and FOIL that out. Whenever you have parentheses squared, you got to write 2 of them. And do the whole FOIL thing. Okay, so, and then boom and a boom. Minus 7x plus 2x squared. This will end up becoming 49. Can I just skip some steps here? Minus 14 minus 28x plus 4x squared. That okay? Like that. Gather like terms. 9x squared and 4x squared is 13x squared. 1 and 2 makes 15. Like an auctioneer. Can I hit 2, 2, 2, 15? All right. And then minus 7x minus 28x is minus 35x. And then I'm going to subtract 39 from both sides because I want a 0. Plus 10 equals 0. Not too quick? Like that. And also, I would like factor out a 5, make life easier, or divide by 5, whatever one you want to do. It's going to be the same effect. I'll take out a 5. 5 times 3x squared minus 7x plus 2. You don't have to do that, but that would make the factoring a little easier for you to do that first. All right, I need a fresh screen, I think, to finish from there. Y'all got that copied down? So we got to factor more. You got to do the 2 parentheses and factoring from there. Or you could do the quad. Some people just like to just do the quad. It's always the same, negative b plus or minus. You know, do that whole thing if you want. Got that down? You okay if I move screens there? So 5, 3, 3, 7, 2. So we're at 5, 3, 7, 2, like that. So that's where we're at. Everybody got that down? Good. All right, so now keep factoring. So 2 parentheses, 3x times x. Remember, it's FOIL, right? F-O-I-L, front times front makes front. Remember how this works? And then last times last makes last. That'd be 2 times 1. But it's not like that. That's the wrong order. I'm doing it wrong on purpose so I can show you. So if you think it's that, just try it and check, right? I have nothing more magical to say to you than that. Try it and check. What signs? Well, they got to both be negative because they're multiplying to be positive and adding to be negative. Remember, they add in the middle, multiply on the right side. So they got to both be negative. Try that. See, that won't work. If you FOIL that, I'll just leave the 5 there. Leave the 5 out of it. 3x squared minus 3x, and then boom and a boom, minus 2x plus 2. So that'll make minus 5x in the middle instead of 7. See how that's not working? So then you go, oh, okay, let me switch them. So I put the 1 here and the 2 there. Try it again, and now it'll work. Now when you check it, you'll go, okay, let's see, 3x squared minus 6x, because 3 times 2, right? That 3 goes to the 2. And now minus 1x plus 2. So that makes what? Minus 7 in the middle. Oh, yeah, that's it. So there it is. You just got to fiddle, fiddle, fiddle. And the more you do that, pretty soon you can see those in your head. You'll see them while you sleep. You'll know them really well, which is what you want. You're going into Calc, especially if you're going to Calc 2. Help my daughter with Calc 2. In fact, that's the afternoon agenda, is to get her ready for another Calc 2 exam. Algebra everywhere. Crazy. It just reminded me. Calc 2 is really Calc 2 is the step. Calc 2 especially. It's just crazy with it. Like, it'll make these look, like there's problems 3 times, no exaggeration, 3 times as long as these in Calc 2. Just factoring and algebra, just everywhere, everywhere. Crazy, crazy, crazy. So you really got to learn that stuff. I just erased the whole thing. What am I doing? I can't talk and work, you know? That's a problem for a teacher. All right. So there we go. All right. So back to it. Now, we got to set things to 0. Set things to 0. Not the 5. The 5 is irrelevant because it doesn't have an x. Do you know what I mean by that? Does that make sense? Logically, it'd be like if I told you, hey, 5 times something is 0. What does that mean? Well, it just means one of those somethings is a 0. It doesn't mean anything about the 5, does it? The 5 is just 5. He doesn't have an x. He can't vary. If you don't have a variable, you can't vary. If it was 5x, then I would go, yeah, he can be 0 too. He could. If he had an x, he could vary, he could be 0. But if he doesn't have an x, he's just 5, and he doesn't make anybody 0. So I totally skip him, and I just go, look, 3x minus 1 is 0, or x minus 2 is 0. Roberto knows. Go see Roberto. Any of those questions. 3x is 1. Divide by 3. Move the 2 over. So we got our 2x answers. That okay? Did you guys get to there? Okay, 1/3 and 2. I enjoy. I'm not just glad. I enjoy helping with that. Come see me. I'll be glad to do all that algebra with you. It's fun. We'll have fun. So I tell my daughter when I go home in the afternoon, it's a calculus party, right? We'll get some snacks out and we'll crank through calculus. And she's like, all right, Dad. Anyway, so, right? So come on, see me. All right. So we got our 2x answers. We got to get our y answers now. All right. So how are we going to get our y answers? Yep. Plug into the easier one, right? Plug into the easier one. Since you have your choice, which one's easier again? Yeah, the first power one. That second one where the things are first power. That one's easier. Yeah. So plug in. So plug in to the 2x plus y is 7. So grab that x, plug it in. So we'll get 2 times a third plus y is 7, like that. And now, how do we solve that thing? It's a little messy, huh? You can make that 2/3. That's really 2/3 plus y is 7, isn't it? Right? Multiply through by 3. You can subtract 2/3 if you're comfortable with that. Get 6 1/3 and then convert that to 19/3. If you're good with that. If not, just multiply through by the denominator, which is 3. So 3, 3, 3. These are so long. Cancel. 2 plus 3y is 21. Right? Multiply through by 3 there. Subtract 2. 3y is 19. Divided by 3, 19/3. So that's the y value that goes with x 1/3. Did you track with me on that? So x 1/3 goes with y 19/3, right? The x 1/3 we plugged in and found y 19/3. Is everybody okay with those steps? They take practice. They won't come to the casual. You got to practice, practice. Okay, then the 2 should be a little easier, I think, because it's just a nice whole number. So now we're going to plug in again. Plug in x is 2 to the 2x plus y is 7. Grab the 2, pop it in there. 2 times 2 plus y is 7. 4 plus y is 7. Y is 3. So that's 2 comma 3. That's the other answer. 2 answers. Tim.
So since we solved for y in the very beginning, can we plug it into that equation and you already have it solved for y? Yeah, the y.
8 7 minus 2x. Yeah, that saves you a step. That's nice because the 2x has already moved over. I got there in one step, but yeah, it saves one step. That is a little nicer. Good idea. Go to where y is already alone since you want y. Smart thinking. Yes. Good. Is that okay? Other questions on that? So I think you know how to do this. It's just a mess, huh? It just, it's kind of like I know how to hit a tennis ball. I played tennis in high school, and when I watched tennis in Wimbledon, and I see Djokovic out there hitting the ball, I think, yeah, I know. You roll over it with your forehand, you lean on it. Yeah, in theory. But when I go out on the court, it doesn't go anything like the way Djokovic hits. It's because he spent hours slamming that ball, right? And his muscles are trained and all that. So that's the same kind of thing. I know it's not a sport, but you can know it in theory, but you got to do these again and again because there's little things you got to weed out of your system. There just are. We all have that. Just little mistakes you tend to make, and only practice will weed them out. So I'm always putting that forward. That's math. That's math and science. It's time, 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 time. It wants your time. So you put that in. You can learn that. I think y'all know it in theory. So number 6. There we go. So so first thing I want to remind you, this time, they're like terms, aren't they? Everybody see that? X squared with x squared, not x to the first, right? And y squared with y squared, not y to the first. They're matching. They're like terms. 7x squared and 6x squared, 3y squared and 2y squared. They're like terms, whereas the last problem, we had some x squareds and then some x to the first. On the last problem, number 4, they were not like terms. They were never going to add together or subtract, right? X squared will never combine with x to the first. So they weren't like terms. But this time they are. So you can use, you can still just do substitution if you want to, but it would be easier. You can use the addition method. Because the addition method is about adding them. You got to have like terms to do it. You can do it on this one, and it'll be a fair bit easier. So I would suggest doing the addition method. But if you really love substitution, you could do it. Could you? Yeah, I'm kind of, I don't know, maybe.
It's a long mess, but
Yeah, it's a long mess. Yeah. Yeah, I know. I'm thinking about what would be, it may be, yeah. Because I'm looking at that second equation. We could solve for y squared. It wouldn't be 2, it would get rid of that 2, and then there wouldn't be any fractions. Plug in, and yeah. But would you know that? Would you know which one to go for? Nah, just use the addition method. All right, so I'm just going to do it. 7x squared minus 3y squared. I'm going to move that minus 7 over, become a plus 7. 6x squared plus 2y squared. Move. Oh, the 6 2's already moved over. So I'm just going to get them lined up. First off, Kelton.
This one is really helpful because you end up, when solving for x, for that you end up with x squared.
Yeah.
And because in the bottom we have x squared.
You can plug in for x squared rather than get all in x. Totally. Yeah, exactly what I'm thinking. Yeah, let's do that. So, all right, so everybody good so far? So we're going to do addition method because they're like terms. It's a little easier. You could do substitution, but like Robert was saying, I think you probably end up dealing with a lot of fractions, and that's a little painful. So, I'm going to do addition method. So, when you do the addition method, you get things lined up first, because we're going to add them, right? Like terms. Now, you got to get somebody to be opposites. It doesn't matter whether you do x squareds or y squareds. You got to make the two x squareds opposites, one positive, one negative, same number, or make the two y squareds opposites. It doesn't matter. The y squareds already have opposite signs, so why don't we just do that? But you could do the x. You can make the x's both into 42. One in positive 42, one in negative 42 by multiplying by the other number, right? Or maybe I'll just do that. No, the y squareds are have the signs. So I'll do the y's. All right. So I'm going to make one of these a positive. The top one's going to become negative 6. The y squared, top y squared is going to become negative 6. The bottom y squared is going to become positive 6. So they'll be opposites. So I'm going to multiply the top equation by 2, bottom equation by 3. Everybody see what I'm doing there? 14x squared minus 6y squared is 14. This is 18x squared plus 6y squared, 186. 186. Everybody tracking with me? You see what I'm doing there? And then we're going to add them up and see how the y squareds cancel by design on purpose. We made them opposites, right? And this will be something, right? What is that? 32x squared. Is that what that is? 28, yeah, 32, right? 32x squared, and that's some big number. 190, 200, it's just 200? Yeah, just 200, huh? 200 even, that's nice. It's nice when the numbers come out. So 32x squared is 200. Am I racing ahead of you? Is this good? Divide by the 32. And, I don't know. 8, divided by 8, top bottom maybe? 8 would be 50. All right? No, I can't do 825. 825 fourths divided by 8 top and bottom. I think I did that right. Is that right? Remember, we could just they don't want decimals, I think.
25 fourths is 21 or 6.
How do I know? It doesn't say, does it?
25 fourths.
Yeah, just leave it like that. Oh yeah, and now we got to root it. Oh, this is where Kelton was saying, look, you could just leave it x squared. It's kind of convenient. That's true.
You will have to get x eventually.
Yeah, eventually, huh? How about I just get x right now and then plug it in and it'll go right back. Yeah. So go ahead and square root of both sides, up and down the ladder, that whole thing, plus or minus 5 halves. As root of the 25, root of the 4. So x is plus or minus 5 halves. So we got our two x answers. And notice we're about to plug in. I don't have to plug in plus or minus separately because I'm plugging into squared. X is squared. There is no x to the first power anywhere. So there's no difference then between plugging in plus 5 halves or minus 5 halves. It's all squared. It's all going to become 25 fourths positive when I square it. So I can just do one step, one flow. I don't need to do two separate flows, one for the plus and one for the minus. They are one, right? So everybody good there? So we got x is, so we're at x is plus or minus, what was it, 5 halves? Is that right? Everybody got that copy down okay? So I'm going to plug in, you can plug into either equation because they're equally hard or easy. They're one's not easier than the other in this case. They're like terms, they're like each other. So just plug into either. So I'll just, I don't know what I'll do. I like that second one. I'll take that second one. Did I already have y alone somewhere?
No.
Oh, I didn't. I was trying to do your guys' plan, but can't do it. It's only the substitution method, huh? All right, so grab that plus or minus 5 halves. Plug that in for x. See how either way, plus or minus, not root. Why did I do the root? Because I'm talking and I can't All right, plus or minus 5/2 squared. Either way, it's going to make no difference, huh? It's going to be 25/4 after it's squared positive. And we get to here. 6/1 goes to the top. 6/4 is $1.50, right? 2y squared is 62. All right, how are we going to solve that? Multiply through by 4, right? We got those fractions, multiply through by the denominator. Right? Everybody with me? Cancels out like that. So you get 150 plus 8y squared is 248. 248, subtract the 150. 8y squared is 98. So I'm up here, 8y squared is 98, divide by the 8. Y squared, is that reduced? Divide by 2, top and bottom, 49/4. Root it, up and down the ladder. Y is plus or minus 7/2. So we got it. Now, what's the final answer? We got to list out all the answers. On this one, what's it going to be? I'm a little confused myself.
5/2 and 7/2.
Yeah, every combination, huh? That's all it is. Yeah, thanks, Robert. Yeah, you're totally right. It's just 5/2, 7/2, and then just do all the variations of the signs. Yeah, it's because the plus or minus goes with the plus or minus in every possible configuration because the signs worked any which way, remember? So I'll write it 4 times, and I'll go plus, 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 minus, minus, plus, minus, minus. Every configuration of signs. Comma, put a comma between all those. They have a plus or minus button, don't they? Will they allow you to do that?
I didn't try.
I think they might not allow you to do that, even though they have the button. I think I remember in another class trying that, and even though it was there, they didn't like it. Anyway, so just a warning, I think they might not allow it. You have to type in all 4 with the various signs. Commas between them. All right, is that good? Questions I can answer? Are we happy with that? Messy business. 8 of those total. We've done 3. Oh. All right, so yeah, let's do number 10. Again, graphing utility. So we're going to use our graphing calculator. But to use your graphing calculator, you got to have y alone, don't you? Because the graph calculator is y1 equals y2 equals. You got to get y alone. So that means you got to take the first equation, x squared plus y cubed is 1, and solve for y. So move that over. Y cubed is 1 minus x squared. Then what do I do to finish getting y alone? Cube root it, right. So let me just write this out. Yeah, you take both sides to the 1/3 power, or cube root, same thing. 1/3 power cube root, same thing. These cancel, and you got y alone is 1 minus x squared to the 1/3 power. Cube root. You don't have to put plus or minus. Remember, it's only even roots that can vary signs, and you got to put plus or minus. We don't have to do that for an odd root. Right? You guys know what I mean? The square root, the cube root of -8 is just -2. It just stays negative. -2 times -2 times -2, 3 times is -8. Cube roots don't hide signs. Right? But square roots of 4, that could be plus or minus 2. That's not technically right, what I wrote, but I'm trying to make a point. Technically, roots are only plus. What I should have said is the answers to that are plus or minus 2. That's true. Anyway, you got it. Come see me if you want to talk more about that. So there's our y1. Type that in your calculator as y1. This one, I got to solve for y also. So y equals 5 over x cubed. That's your y2. So type in y1 equals 1 minus x squared to the power of 1/3. You got to put parentheses around that 1/3. y2 is 5 divided by x cubed. Like that. Graph and do the intersection. Remember that? The second calc, intersect. You got to graph it, and then second calc intersect and find the point where those two intersect. We have a minute. We have 2 minutes. Let me finish passing out your test. And negative 1.62. Was that x? Anybody else get that? We'll have to assume that's right. All right. Have a good day. These do tomorrow's homework.